Okay, so I wanted to do a little video on why I like F sharp. It's one of the languages that I've really been enjoying writing recently. I just want to start off with a couple of points on evangelizing F sharp because I think it's something that happens quite often. So I've noticed there's a general perception around F sharp, mostly negative, and it has to do with, I think, the fact that Microsoft's involved, and I don't really understand that point of view too much, but I have seen pushback from more than one person just flat out saying, I don't want to use a Microsoft language. I used to be like that, but it's something that doesn't really bother me anymore. Another thing I think is that there's a functional programming stigma in the industry. It's seen as like inaccessible for your average devs and things like that. But I did watch a Scott Voloshin video recently where he said that F sharp is actually a really good enterprise language for reasons that we'll get onto. There's another blog post I read, written a few years ago now. I think it's titled Why Your F sharp Evangelism Won't Work. In that blog post they get into the concepts of early adopters versus pragmatists and how you have to cross the chasm, which is the gap between early adopters and pragmatists, where you find pragmatists who are having problems in their daily work and you give them a solution that justifies using an early adopter language. And the problem with this is that C# isn't bad enough of a language to justify this ever really happening, and the fact that C# is continuously improving. So my opinion is that F# is accessible. That's not necessarily saying it's easy to learn, because there is quite a lot to the language and you can get quite advanced if you need to. It's more saying, I've noticed when reading material about F# that educators often mention things like talking directly with stakeholders and showing them code directly, so that you have a common language between the developers and the stakeholders, and that really allows all parties to kind of understand each other. So from that perspective, the nice syntax can help. I'd consider it to be an elegant language as well. The types keep your code maintainable versus, say, Python, which is a language that I'm most familiar with. And what this maintainability means is that the language works in the large and the small. You don't really pay a cost in the small, but you still get the benefits. And in the large, you really reap the rewards. You also get better organization features like namespaces, which I think is actually in F# terms mainly used to work with C# code, but anyway, it's another way of organizing code, even though you get modules too. There are some core guidelines around this. And you also get access control, like you can make functions and variables private within a module, which TypeScript and JavaScript have, but Python doesn't. I suppose I'm mainly coming at this from the angle of a Python developer, so that does skew my opinion quite a lot. Another way it's elegant is the syntax feels very lightweight and it's aesthetically pleasing. It's one of those things where maybe I've overthought this, but making things easy at a syntax level make it easy to iterate and make changes, and the language just doesn't get in the way of your train of thought. It's also expressive. You can use powerful types to model your domain, and having an expression-orientated language does lead to maybe more succinct code than some other languages. It's highly available. It's supported by many platforms, all the major ones you can really think of. I'm not sure about its support for less popular platforms like BSD, I don't know. But if you want to create a desktop app, a web app, or a mobile app, then you should be good. Finally, it's financially supported, which is a good and a bad thing. From a bad perspective, Microsoft can technically do whatever they want with the language, and maybe Microsoft don't have the best history of being good actors. But what I've noticed is they're a bit more hands-off with F# compared to C#. In fact, sometimes this is to a detriment that the language feels a bit forgotten, but in a way I think some people prefer that. All that to say that when you're an early adopter, you go through these languages and, to be honest, they mostly have a bus factor of 1 and you don't know when they could stop or anything really. I've known a couple that have just faded away, but that doesn't seem likely with F#. So onto the language. In general, it does provide some nice features, some nice syntactical features, and there's quite a lot of ways you can make your life easier. You have pipes, which I know some people love, where you just declaratively state how the code's going to execute, and this is one of those cases where it's easy for non-technical stakeholders to come in and look through and see what's going to happen. type providers, which I'll show an example of in a second. Pattern matching guards, these are kind of like the table stakes for functional programming languages, and even non-functional programming languages these days, like Python has pattern matching and guards. I'm not too sure about the story around destructuring in pattern matching in F#, because I know in a dynamic language you can go a bit crazy. Clojure has some mad syntax for that. You got option result types, again, table stakes. There's object programming, which I know is going to be a major turnoff for some people, and to be honest, I don't really know how I feel about it too much, but it is useful when working with C# code, and there are some cool guidelines around that. I think OOP is generally recommended for when you're working with side effects in F# code, things like file handles, etc. As for the compiler warnings, one of the ones that comes up regularly for me is when it tells you that your code is overly constrained in generics, which is useful to know about. You can omit types to make the code more compatible with a wider variety of use cases. It's nice that the compiler offers something like that. This example at the bottom just shows some pattern matching on an optional type, where check is a function name, A is the optional, and you can see how the type is inferred there. That apostrophe A means a generic type, like you would have capital T in C++ and C-style languages, and the trailing option is the way you can write option, but you can also do it the other way around like C# would. And unit's kind of like void. In this case, the first call to check will print got nothing, and the second will print cool value 12. The $ is an interpolated string. The unintrusiveness of the types is something I was talking about when I mentioned programming in the small. You can see here that the first example is the Python code for a calculate function, which takes 3 parameters and returns a calculated result. And the second example is the F# equivalent. It's optional to provide types for your parameters. So in this case, they'll be inferred to be generic, but the compiler will know that they have to be compatible with each other based on the multiplication and addition operators. So when you call the calculate function, it will be appropriately constrained and type safe. As for the domain modeling, this is something that people talk a lot about in F#, probably because it's one of the key features that makes it a very nice language to use. So there's a famous blog post called Parse Don't Validate, and essentially what it means is that instead of validating inputs and throwing errors when you encounter invalid input, you pass the input and the result of the parsing is a new type which you can pass around and make sure that you're safe at the type level. In this case, this might be some code you would see in a web application where we want to store a new user based on registration. However, we want to be sure that the store user function takes a safe password, not just a plain string. So we create this safe password type, which is a discriminated union with a single case, which declares that safe password is its own type and it's associated with some data, which is just the string. Hash password is our parse don't validate function, and you can see that we pass a raw string which represents the input password into the function, and we return a safe password. And then in the body you can see we have a pipeline set up which takes the input, passes it into bcrypt, which is going to return a string, but the string is the hashed representation of the password, and then pass that hashed string into safe password, so that we can pass around a value with the type of safe password that has the associated data of the hashed string. Then store user takes a DB and a username. The username is just any old string, and it must take a safe password. You can see a difference between the password and the username parameters. The colon shows that the username has the type of string, but there's no colon for the password. That's because we're omitting the type declaration for password, and what we're doing instead is destructuring in the function parameters the string data associated with safe password into the password variable. Then we call dbSave with the username and the password, where in this case the password is the hashed string and it has a type of string at this point because it's been destructured. Then the examples of calling the store user function below, where we can't call it if the value for password is a string type, so we have to hash the password first before sending it to the store user function. Falco is a micro-web framework that I've used a bit, and this is the style of code that you write for their HTML templating. I've seen quite a few HTML DSLs through the years, and this isn't really too different. The structure is simple, where you just pass attributes as the first list and children as the second. So you have that same hierarchy that HTML code would have, but it's just done in a type-safe way. Having type safety at the HTML level is really nice for refactoring. So while this may seem like a lot of overhead for something so simple, it does pay off in the long run. Also, even though I mentioned DSL, note that this actually isn't a DSL, it's just a normal F# function call with 2 parameters, which are both lists. Now I'll just do a quick demonstration of some F# code. So when you're creating an F# script, you can use this #r directive, which tells the package manager to gather a new package that you want to use. We want to use F# data, we can provide the version, and then when we run the script, it will pull down this package for us to use. And we open the package, .data, and we can use JSON provider from this package to look at an API and give us some types from it. So if we use the Star Wars API as an example, JSON provider, you can either pass it a file or a URL, and it will gather that resource and use it as an example to construct the type. I don't think I need to provide the page, but that's how we're going to be using the API, so I like to do that. In this case, what I want to do is go through the pages of the API, pull out all the people, and then get some information about them. So for that, we can use a recursive function, but F# does let you do it in an iterative way as well, although F# supports tail recursion, so there's no penalty. We define a recursive function like this, and car is going to be our current page to look at, and you can see from the example URL that's going to start with 1. So we can use the type from the provider to pull data from that API using the people.load function. Here we're using an interpolated string to go through the pages one at a time based on the parameter of the function. We check that the page's next value is set. Because the initial page has a next value set, it gives it the type of string, which means that for the final page, even though in the API the value is null, it will be cast to a string, and null will get cast to the empty string. So this is how we do the check. It's not ideal. I'm not sure if you can tell the provider at some point that it is a nullable string, or it would be a string option in F#, I suppose. Okay, so for each page, we go through the people on the page. The API isn't really designed as nicely as you'd hope for, so in this case, the list of people isn't called people, it's called results. So the type provider gives us the results with not a very descriptive name. So in this case, I just want to print some information about each person. So for this, we're going to need to add a new describe person function just to print out some information. And then before we do that, I just want to finish off the loop. You can see that the brackets are optional here. We want to sleep for half a second before calling the function again, just so that we don't hit the rate limit for the API. Before we create the new function, you can create type aliases in F#, and this is a case where it might be quite nice. Because the provider sees results in the API, it gives an individual type of a person the type result. But we want to use a more descriptive name, so we can just create an alias and call it person instead. Then when we create the describe person function, we can tell it to take a person. This is not like a new type or a distinct type, it's just a simple alias, but it's a bit more readable. And also note that I can omit the return types here. So what we're going to do is wrap this in a try, because we're not sure what kind of errors can occur. Then we want to match person.height. We're going to create an active pattern here, which gives us a discriminated union, and we're going to use that to determine whether people are tall or short. So the active pattern takes a height. So if the height is greater than or equal to 150, then tall, else short. Then to call the active pattern, we just have to pattern match on the values of the pattern. So here we have short, and we'll say person.name is short. Otherwise, tall, and that covers the cases for our active pattern. But the other thing we need to do is add the exception case. That's our describe person implemented. Now all we have to do is call it. So this should go through the whole set. I suppose I didn't really highlight the type information too well, so I'll just show you quick. I'll run the example first because we're sleeping, so it'll take a little while to run. Here you can see how we run a F# script. We have the .fsx extension, which tells the .NET runtime that it's a script, and then we just pass that to FSI, which stands for F# Interactive. If you run it without a file, it will give you a REPL, and with a file, just run the script like Python or something. So if I go back to here, we do get some autocomplete on person. So here you can see all the properties that come from the API. So we're type safe, which is very nice. And we can see here, here's the exception case as well. And that's pretty much type providers in a nutshell. You'll hear the term functional first get thrown around a lot with F# code. It's one of those things that doesn't really have much meaning, but essentially it means that you can write code in a functional style and it feels like a functional language. It's not a purely functional language, so you do get some leeway with some of the ideas that are commonly found in functional programming. It's sort of treated like an ideology among F# developers. It's one of those things that when you write Python, there's not really any particular way to write it. So in that sense, it is actually quite nice to have an ideology and a general guideline for how to write code. And this list has a couple of things that you'd expect as table stakes in functional languages these days. On the escape hatches point, F# has exceptions, and I think some of the other functional programming languages have exceptions as well. It's not necessarily a shame that they're in the language at all, but I do think it's a shame that there's no effect tracking, so you don't have something like Java throws, so you can call functions without knowing whether they're going to throw or not. There are also guidelines around the use of exceptions in F#, where I think the advice is generally use the type system for domain errors, but runtime errors should use exceptions. And this is apparently because using the type system to try and encode arbitrary errors can lead to fragile code, which in theory I think I agree with. F# is a very pragmatic language. The OOP is going to be a big turn-off for a lot of people, and to some extent me too. In fact, when I'm writing languages that support OOP as a first-class paradigm, I tend to shy away from it a little bit. I'm one of those people who prefers using value types, structs, and plain old data and passing that around to functions. Although I think typical F# code doesn't really rely on OOP so much. One of the reasons I choose F# is because I want to avoid some of the C# design pattern bloat that I tend to see. I think there's a lot of over-engineering in C# code bases and projects, and I tend to prefer just simple functions and straightforward data flows, especially as a solo dev. Unlike some other small languages, F# has pretty good tooling as well. There's good IDE support if you like IDEs. I don't really, but there's LSP support, so that's not really an issue these days. F# Interactive gives you a REPL. There's Jupyter Notebook support, although I've never used it. I think it could be useful for some use cases. It's not always common to see such first-class tooling in smaller languages. There's also more advanced features like computation expressions and active patterns, which lead to very expressive and maintainable code. Onto the ecosystem. The interop's trivial with C#, and you get full access to its standard library, which is one of the killer features, like having the string stuff and link. It's just so useful. There's years and years of effort gone into that. I think generally in programming language ecosystems, the quantity aspect is significantly overblown by people, and that while you're more likely to find quality libraries in a larger ecosystem, the most commonly used ones aren't necessarily high quality, and I can think of a few in Python which are low quality and widely used. Nevertheless, in F# we kind of have both, because we have access to a huge number of C# libraries, which are easy to use, but also the F# first libraries that are available tend to be quite high quality, although that's highly likely to be selection bias on my part. But in the worst case, you do still have a lot of options. You can also run F# files as scripts, so you're not committed to creating a full-blown project every time you want to write some F# code. You can use the .NET FSI command as a one-time thing. And as I mentioned at the start of the video, the language is supported by Microsoft, so not likely to go away anytime soon or lose all its developers. These are just some examples of the libraries available to F# developers. You have game engines if that takes your fancy, or like I said before, if you want to create web apps or desktop apps or mobile apps, you have all these available, and there's probably more. These are just some I've pulled off the F# website. Generally speaking, F# has the same performance profile as C#, and these days I think C# is regarded as quite a performant language, and a lot of the recent releases of the .NET runtime have had a massive focus on performance. But it's not just the runtime performance that's good, the compiler's fast too. So if you're creating a web app, for example, and you want live reload, the compiler's fast that, even though it's not as fast as something like V, it's still quite a good developer experience to work with. I'll just quickly cover my perspective on F# if you're coming from other languages. So for Haskell and OCaml, I think developers won't necessarily be that interested in F# because there isn't quite as much focus on the fancy type system stuff. In terms of OCaml, F# probably slower because it's not native compiled, although I guess this does depend on what kind of workload you have. And as for Haskell, faster compile times could be nice. I've seen a recent push in the Haskell community for simpler code as well, I'm not sure if that's something that's really caught on, but F#'s something that's definitely in a position to offer that. For dynamic languages like Python or Ruby, I think the upgrade here is a no-brainer. Maybe more for Python than Ruby because F# code feels a little bit more Pythonic than Ruby-ish. I think that Ruby developers have a very specific idea of aesthetics when it comes to language design and syntax, and F# isn't really aiming at that. But in terms of performance, it's certainly something to consider. I'm not really sure about the story around Ruby's type system recently, but I feel like I'd take a well-integrated type system and compiler, especially of ML heritage, and an algebraic type system over a gradual type system any day. As for Python, I'm a little bit down on Python these days, but it kind of does feel to me that F#'s a strict upgrade in every way. I'd like to hear some opinions on that, but I can't think of any cases off the top of my head where Python is better than F#. Clojure and Scala give you the JVM aspect where they're both similar runtimes, .NET and JVM. I don't really have any experience with Scala, so I can't speak about it much, but I think F# and Scala have very similar use cases. And I have heard that the perception around Scala isn't that great recently, so I'm not sure what's going on there. Maybe it's a bit political. As for Clojure, I don't really see that much overlap between Clojure and F# because Clojure's so opinionated, and the people who are interested in Lisps tend to want to get something else out of the experience than ML-style functional people. I definitely think that you can like both languages. I think that you can use both languages for similar use cases, but there is a very strong aesthetic divide between the two, and especially because Clojure is dynamically typed. Although I'm not strictly a everything be statically typed guy, because I do see a lot of merit in the way Clojure does things. It's one of those depends on how you feel on that day of the week type deals. As for Rust and C++, I thought I'd mention it because that's the other category of language that I haven't really addressed, the ultra-fast system style stuff. I think historically it's very hard to get C++ developers to move off of anything that isn't almost identical to C++. So I'm thinking that F# is probably quite unattractive to C++ developers. But Rust, well, Rust developers are very opinionated too, and you're not going to see the level of performance that you do in Rust. But I think maybe if you got that kind of overthinking burnout type situation, F#'s a bit more of a laid-back language than Rust, but offers some of the similar ideas and features like pattern matching and options, results, things like that. You never know, maybe there is some hope there. I hope that I've conveyed well some of the reasons that I like F# as a language, and I hope that you consider picking it up at some point and trying it out.